Welcome back. This is Beginning Algebra, Lesson 14, Solving Inequalities, Part 1. Let's do example number 1. There are many ways to write equations. Sometimes they're equal to, and sometimes they can be something different. And this example we're going to give as, we can say less than, or we can say greater than, or we can say less than or equal to, or we can say greater than or equal to. So we can say 3x plus 1 is equal to 25. Or we can say 3x plus 1 is greater than 25, 3x plus 1 is less than 25, or 3x plus 1 is less than or equal to 25, 3x plus 1 is greater than or equal to 25. These are just different ways of solving different kinds of problems. And you'll see here in a minute what I mean. There is a certain way to graph these things. If you're using just a less than or greater than, we use an open circle. And then we point the arrow to whatever. If it's greater than, we go to the right. If it's less than, we go to the left. This just shows you if it includes the number or just means that it has anything bigger than that number. So if we say 3 is greater than x, we can write it as this, with an open circle and 3 going to the right, meaning it's greater than 3, but it does not include 3. So we can also write as x is less than 3. All that's saying is it includes any value that's below 3 but does not include 3. And then we can write this graph representing x is greater than 3. So if x is greater than 3, then that means it can be any value above 3 but not 3. Let's go to number 2. If x is greater than or equal to 3, you can write it this way. Make a closed circle. X is greater than, it will be to the right. So this means any value greater than 3, including 3. So if I choose x to be 4, we can say that 4, representing x, is greater than 3 or equal to 3. And that would be true. Or we can say that x is equal to 3, and then we can say that 3 is greater than or equal to 3. And that is still true. So if we want to write out x is less than or equal to 3, we can write it this way. It's including 3, but it's less than, so it will be to the left. So x is any value greater than 3 and includes 3. So for example, if we say x is 1, 1 is less than or equal to 3, that would be true. If x is 3, then we can say 3 is less than or equal to 3. That is still true. So let's go to number 3. If we have 2 is less than 1, this means we have a false statement and there's no solution. If we say that 1 is less than 2, this is a true statement. If we say that 2 is less than or equal to 1, this is a false statement and there's no solution. But if we say that 2 is greater than or equal to 2, this is still a true statement. They're just different ways of writing out what you want to describe. So let's graph these. So if we have this, 2 is less than 1, what would that look like? It would just say there's an open circle. This would just be, the numbers are on the line, but what you're trying to describe mathematically, it wouldn't make any sense. It would be false. Because you have number 2, and you're saying that it's less than 1, but it's not because it's a bigger number, so 1 is a smaller number. So you cannot say this because it doesn't meet the criteria of your description. Now if we go to the next one, 1 is less than 2, we can say that 1 is less than 2 because 1 is further left on the number line than 2 is, so that would be true. Now if we say 2 is less than or equal to 1, we know this isn't true because 2 is a bigger number and 1 is a smaller number, and that wouldn't work. Now if we say 2 is greater than or equal to 2, we can say that they're the same value, they are equal, so that is checked, that is good. Let's move on to number 4. Say we have a negative 1 is less than x, or we have x is less than 1. So let's draw this number line. Let's find out where the negative 1 is and x. You can also rewrite it as x is greater than negative 1. So basically saying x is bigger than negative 1. Or we can say negative 1 is smaller than x. Both of these are the same. They're just saying the same thing, but in a different manner. So if you wanted to graph either one of these, you always remember that when we're doing greater than or equal to, or less than or equal to, it's a closed dot. If you just do less than or greater to, then we just do an open one. So this one is just basically saying x is bigger than negative 1. So as a graph, you can say open circle, because you're not specifying that it's equal to. You can say x is any number that's greater than negative 1. So it would go to the right. So if you have 2 of these like this is kind of like giving you a boundary, a mathematical description of a boundary. So when you have negative 1 is less than x, and x is less than 1, then it's a boundary between the two. So you can say, let's draw this out. Between these 2 points, negative 1 and 1, since they're not equal to, they're just greater than or less than, we can write with an open circle. So we can say basically x is any value between -1 and 1, but not including -1 or 1. So this is written either as x is greater than -1 or x is less than 1. And this just gives you, also can make it a compound description as this. -1 is less than x and x is less than 1. This would be your lower end or your lower bounds, and the other part would be your upper end or your upper bounds. It's just a quick way of showing you your information you're looking for is between these two numbers. The x is in between these two values, -1 and 1, and this is just a way of writing this upper and lower bounds. Let's move on to number 5. X plus 1 equals 20, or we can have x plus 1 is greater than 20. We just solve it just like a regular equation by isolating the x. Let's move the 1 over, so let's subtract 1 on each side. So we get -1 plus 1 plus x is greater than 20 minus 1. So you get x is greater than 20 minus 1. So you get x is greater than 19. We can graph this simply by placing an open circle above 19. And since x is greater than, we'll move it to that direction, greater than. The x is bigger, so you want to go to the right. The same way we do this equation as we did on the other side. We move the 1 over, we subtract it, and we get 19. But x is 19, so you just have 1 point on your number line. See how these two equations are very similar, but they tell you different things. Let's go to number 6. X minus 3 is less than 20. Let's isolate 3 away from the x. Let's move 3 on the other side. Do this by adding 3 on both sides. That eliminates the 3 where the x is and brings the 3 on the other side. So the 3 minus 3 is 0. And 20 plus 3 is 23. So you're left with x is less than 23. So we graph this, draw a circle above the 23. It's an open circle because we don't have equals to. It's just a less than sign. So we have 23 going to the less than's, which is to the left. So the numbers are decreasing. I could always remember this. You always follow the path where the symbol less than or greater than, because greater than goes one direction and less than goes the other direction. Less than goes to the left and greater than goes to the right. That's how I always remember how to graph it. Alright, this concludes lesson 14, the part 1. We will do the next part in the next segment video. Thank you for watching. Please rate and subscribe.